Bismillahirrahmanirrahim. In this short video, we'll try to understand the difference between decimal and binary numbers. Now, as we know that the decimal number starts from 0 and goes up to 9, and it is thought that is based on the fact that the human beings have 10 fingers, so these are the 10 numbers. And if we call the first digit as 0, then 9 will be the last digit of the decimal numbers. And if we go further, then you know what we do, that in place of the 9 or the unit place we put a 0, and then at the 10th place we put a 1. So after the last digit, then we move towards left and put 1 and 0. Similarly, if we keep counting and we go up to 99, then what happens? Both are the last digits, 9 and 9. After that, then we move further towards left and we put a 1 and 0. So same technique will be used in case of a binary number. Now the basic concept of binary number is that if a person has just one finger, how would he count? So when he closes this finger, we call it 0, and when he opens the finger, we call it as 1. So 0 is the first digit and 1 is the last digit in the binary digits. Now what will happen if we go further? So like here, after the last digit, we get 1 and 0. Same here, after the last digit in binary, we'll go for 1 and 0. And then if we go further, then we'll have 1 1, so it will 1 1. Now again here both are the last digits, so what will happen if we go further? We'll have 1 0 0. So this is how the number progresses in the binary digit system. And if you compare the two, this is 0 0, this is 1 and 1, and 2 is equivalent to 1 0, 3 is equivalent to 1 1, and 4 is equivalent to 1 1 0. Okay, now a question might come in mind, why don't we use the decimal numbers in the computers? Okay, the problem here is that for any number or any information that we send in the computer system or outside, we have to represent these with the help of a voltage. So let's say we take these voltages. For 0 we use 0 volt, but to represent 1 we use a 5 volt signal. Then for 2 we use a 10 volt signal, and this way for 9 we will be using 45 volt signal. So the first thing will be, you can notice that we got to have a very large power supply which can provide all these voltages. And the second and the most important problem of the system is that, let's say we want to send a value 294, then for 2 we have to send a 10 volt signal, for 9 we have to send a 45 volt signal, and for 4 we have to send a 20 volt signal. Now this is a very big shock, big jump in the voltages, 0, then 10, then 45 volt, then 20 volt, and our circuit will not be able to bear this. And that is why computers, this system is not practical for use in the computers. So the scientists came up with the binary numbers idea, and as we had just seen, that the binary numbers are represented like this, that for decimal 0 we have a 0, then for decimal 1 we have 1, but for decimal 2 we have 1 0 and then 1 1, and this way we can progress. Now if we represent as we did here, for 0 we use 0 volt, but for 1 we use 5 volt. And now nothing more than 1 in this, and therefore we will be only playing with 5 volt and 0 volt. And if you see graphically, This is 0 volt, this is 5 volt. In this case, 50 can be represented as 5 volt and 0 volt. And then for here, that is 3 can be represented as 5 volt and 5 volt. So the maximum jump is from 0 to 5 volt, and therefore we need a very simplified power supply system to handle this data. Okay, now here if we want to send number 294 in the binary form, then we can see from here 2 is 10, so we write 10, then 9 is 1001, and then 4 is 100. So we can send this binary number. But there is a problem at the receiver end. How would the receiver know which one or where to give the gap? After 2 digits, after 3 digits, after 4 digits. So the computer is confused or will be confused. And to avoid this, the scientists, they came up with an idea of having 4 bits, 4 binary digits for all the values. And if we have more than 16, then we can increase the number. But generally, we take this as a standard, that is 4 bits. Now, what will be the advantage of this 4-bit and all the numbers? That when you send this number, now you will send, for 2 you will send 001, for 9 we will send 1001, and for 4 we will send 0100. So at the receiver end, we know that this number is up to 4 bits. So it will easily detect the first 4 bits and say it is 2, then the next 4 bits and then interpret it as 9, and the next 4 bit and interpret it as 4. So this is the commonly followed convention for binary numbers writing. Okay, and when we are writing, we write base number 10 for the decimal numbers and base number 2 for the binary numbers. So if you are talking of 12 decimal numbers, we can write 12 and then the base 10 to make you clearly understand that this is a base 10 or the decimal number. Similarly, for binary number, we write 1100 and then we write base 2. Now this is not very common. This is only followed when there is a chance of confusion between the two numbers. And similarly, 19 in decimal can be written as this in binary. But see here, 110 and 110. 110 in decimal number is not same as 110 in binary number, because this is 110, but this is actually equivalent to 6 decimal. So you have to keep this point in mind. Okay. There is an easy way of interpreting the binary numbers. The first number, we call it, or the place value of the first number on the right is 2 raised to the power 0, which is equal to 1. Then the second number, place value is 2 raised to the power 1 is equal to 2. And the third one, 2 raised to the power 2 is 4, and then 2 raised to the power 3 is 8. Now, if you know this, you can easily find out the decimal value of any number. For example, let's see this number. Now, this is 8 from here, and then this is 2, so 10. So, this is equal to 10. So, you can easily calculate the decimal equivalent of a binary number by following this method. Okay, just a simple point clarification. Sometimes students get confused about what is count and what is the largest value. So if this is a 2-bit number, so it have possibilities as 00, 01, 10 and 11. So there are 4 counts. But if you go to the decimal equivalent, this is equal to 1 as 0, this is equal to 1, this is equal to 2, and the last one is equal to 3. So the largest number is 3. Count is 4, but the largest number is 3. So we can easily follow with a formula that if we have n bits, we can have 2 raised to the power n counts, and the largest number will be 2 raised to the power n minus 1. So like here we had 4 counts, 2 raised to the power 2, 4 counts, and 2 n minus 1, that is 4 minus 1, 3 is the largest value. And the same thing, 2 raised to the power 4 is 16, and 2 raised to the power 4 minus 1 is 15. So 16 count, and 15 is the largest number for case of a 4-bit. So I hope this gives you an understanding the difference between the binary number and the decimal numbers. Thank you. Okay, one more point is that as we mentioned that for binary 0 we use 0 volt, and for binary 1 we use 5 volt. So this is 0 volt and this is 5 volt. Now what happens when we transmit this signal? The possibilities are that some noise will be accumulated here. The possibilities is also that there can be reduction in this voltage during transmission. So it can go from 5 to maybe 3 or 3.5. Okay, so there is a convention that is followed at the receiving end. Any signal that we receive which is between 0 volt and 0.8 volt, we call this as binary 0. And any signal which is more than 2 volts and between 5 volts, this we'll call it as a binary 1. And anything between 0.8 volt and 2 volt, this will be rejected, not accepted. So I hope you have now some idea about binary and decimal. Thank you.